Welcome to physics scenario classes. Dear students, today I am going to discuss a question of quantum mechanics that was asked in GATE 2010. The question states, which of the following is an allowed wave function for a particle in a bound state? N is a constant and alpha greater than 0, beta greater than 0. Option A, psi equals n e raised to minus alpha r divided by r cube. Option B, psi equals n under bracket 1 minus e raised to minus alpha r. Option C, psi equals n e raised to minus alpha x e raised to minus beta under bracket x square plus y square plus z square. And option D, psi equals non-zero constant if small r is less than capital R and it is 0 if small r is greater than capital R. Now we want to in order to solve it, we should know that for an allowed wave function for a particle in a bound state, we should have wave function psi should take 0 value at the boundaries, because at the boundaries the potential becomes infinitely large, and so there is least probability of being the particle over there. That's why the wave function psi should take 0 value. Here the boundary is plus infinity and minus infinity. Another important property is wave function should be continuous in this interval, that is from minus infinity to plus infinity. It should be continuous. And another property is wave function should also have continuous first derivative on the given interval. Here we have interval minus infinity to plus infinity. Let us check each option one by one. So option A is psi equals n e raised to minus alpha divided by r cube. When r tends to infinity, let us check it. For that we have written psi equals n 1 upon e raised to alpha r and r cube. So when r tends to infinity, it becomes n upon e raised to alpha times infinity, and r raised to q, it becomes infinity to the power 3. So it becomes n upon e raised to infinity times infinity, or n upon infinity, it means it is 0. For r tends to minus infinity, here when you put it, r tends to minus, that is it e raised to the power infinity, and divided by minus infinity to the power cube. So infinity upon infinity to the power cube. So that's create a problem. For that we change this r by minus curly r and then take limit a small r to be plus infinity. Then when we change it, psi becomes n e raised to minus alpha multiplied by minus r, and this becomes minus r to the power 3. So n times e raised to plus alpha r divided by minus of r to the power 3. Now we elaborate it. So it becomes minus n, and this becomes 1 plus alpha r plus alpha square r square upon factorial 2 plus alpha q r cube upon factorial 3 plus alpha 4 r to the power 4 upon factorial 4 plus alpha 5 r to the power 5 factorial 5 and so on, divided by curly r cube. So it becomes minus n upon, divide it throughout, it will become 1 upon r cube plus alpha upon r square plus, it will cancel out and it becomes alpha square upon factorial 2 into 1 upon r plus alpha cube upon factorial 3, this will cancel out, plus alpha 4 upon factorial 4 r plus alpha 5 upon factorial 5 r square and so on. And now we will set limit r tends to infinity. So when r tends to infinity, we will set here this condition, psi becomes minus n 1 upon infinity to the power q, it becomes 0, plus alpha upon infinity square also becomes 0, plus alpha upon square upon factorial 2 1 upon infinity, it also becomes 0, plus infinity alpha cube upon factorial 3. Now we put curly r tends to infinity in this expansion. Then we have psi equals minus n under bracket 1 upon infinity to the power cube, that is it becomes 0, plus alpha upon infinity square, that means it becomes 0, plus alpha square upon factorial 2 times 1 upon infinity, that is it also becomes 0, plus alpha cube upon factorial 3 plus alpha 4 upon factorial 4 times r, so it is infinity, plus alpha to the power 5 upon factorial 5 times infinity square, it means infinity square terms, infinity q terms and so on. In this way we find that under the parenthesis we have infinity times minus n, it is minus infinity if n is positive, if n is negative it is plus infinity. So in any situation when r tends to minus infinity, the wave function psi tends to plus infinity or minus infinity. So this is not a valid wave function, not a valid wave function. Now we proceed for option B. Psi equals n under bracket 1 minus e raised to minus alpha r. When r tends to infinity plus infinity, wave function psi becomes n times 1 minus e raised to minus alpha times infinity. So it is n under bracket 1 minus e raised to minus alpha times infinity, it means e raised to minus infinity, that is 0. So 1 minus 0, it is n. And when n tends to minus infinity, wave function psi becomes n 1 minus e raised to minus alpha multiplied by minus infinity. So it is n 1 minus e raised to plus alpha times infinity. So it is infinity, and e raised to infinity, it means it is infinity. So it becomes n 1 minus infinity. So it is minus infinity times n. So it is minus infinity. So that's why this option is not a valid wave function, because at r tends to infinity it becomes n and when r tends to minus infinity it becomes minus infinity. So it is also not a valid wave function. Now we check option C, that is psi equals n e raised to minus alpha x e raised to minus beta under bracket x square plus y square plus z square. Now keep x terms at one place, then it becomes n times e raised to minus alpha x minus beta x square, and this becomes e raised to minus beta y square plus z square. Now n e raised to take x common, so minus x common, alpha plus beta x e raised to minus beta y square plus z square. Now we apply when x tends to infinity, y tends to infinity and z tends to infinity. We have psi equals n e raised to minus infinity under bracket alpha plus b raised to infinity times e raised to minus beta infinity square plus infinity square. Infinity square. Now it is n times e raised to minus infinity square times e raised to minus infinity square. So this is n, this is 0 and this is again 0. So the output is 0 when x tends to infinity, y tends to infinity and z tends to infinity. X tends to minus infinity, y tends to minus infinity and z tends to minus infinity. Wave function psi becomes n e raised to minus of minus infinity times alpha plus beta times minus infinity. Here we have put minus infinity in place of x and a minus infinity in place of y and minus infinity in place of z. So this comes out to be e raised to minus beta minus infinity square, it means infinity square, minus infinity square, it means also infinity square. So this is n e raised to minus minus plus infinity. Here it is beta times minus infinity, it means it is minus infinity because beta is a finite value. Minus infinity plus alpha, it is a finite value, so it becomes minus infinity. Now this is e raised to minus beta times infinity square. So this is n times e raised to minus infinity square multiplied by e raised to minus infinity square. So it is n times 0 times 0. So this is 0. Clearly when x tends to infinity, y tends to infinity and z tends to infinity, wave function psi is 0. And when x tends to minus infinity, y tends to minus infinity and z tends to minus infinity, we have again wave function psi equals 0. So this represents a valid wave function. Now check option D. The wave function psi is given as non-zero constant if a small r is less than capital R, and it is 0 if r is greater than capital R. So we should draw a graph like, suppose this is r equals r. So when r is less than r, it is non-zero constant like this, and after that it becomes 0. Either this, or when r is less than capital R, like this non-zero constant, and after that it becomes 0 when r is greater than r. When r is greater than r. Clearly at r equals small r equals capital R, there is abrupt change. So the graph is not continuous, graph is discontinuous here. Also its first derivative would become infinity here. So it is also not a smooth curve, not a continuous curve. So option D also does not represent valid wave function. Thanks.